take one, make it multiple, and streamline the management of computing environment. Right? So, you can really look at, okay, what are the reasons why I really would virtualize, server virtualize? So these are consolidations, dynamic provisioning and hosting, workload management. I mean, these are all the reasons why you do it, right? To get better resource utilization. But when you really, if you net it down, I mean, the three main things are reduce hardware costs, right? Improve flexibility and responsiveness, okay? And reduce management costs. I mean, reduce management costs, I mean, we talked about it, right? I mean, that is something, it's debatable. But the first two, certainly. I mean, you are going to really increase your overall utilization. So instead of buying more, you're going to you're going to get more bang for the buck, right? More mileage out of what you already have, right? And flexibility and responsiveness, the fact that you can really spin up a new virtual machine when you need it, instead of really always engineering things for peak load, you have the ability to add resources when you need it. Not to say that everybody is doing it. I don't think 90% of the people are not doing it.
License.
Right? Pardon me?
It's not that they cannot do it. Today's license policies of whether it's IBM, Oracle, or HP, or anybody, do not allow you to charge on micro-partition.
Well,
that is a key driver, because I can't do dynamically, because they will charge you for, if you use 0.25 of a core, they'll charge you for a core.
Not with IBM software. We have license metricing software that really runs. So for micro, what do you call that? I mean, micro partition. Sorry, there is the ability, but you have to have the infrastructure to make sure that you have those tools running so that IBM can really get statistics on how much you're using.
We have to have it. We have to go on and say, I will not go more than 0.5. Oh.
Yeah.
That's what we have to. There's an upper limit, but my LPAR I can dynamically move from 0.1 to 0.9 back and forth.
Mm-hmm.
It's not technically, yes.
Yeah.
No, I mean business-wise, license billing is a
yeah. I mean, if I talk to my salesperson, the salesperson would say, I want my customer to use as much as he or she wants. I'm going to do a true up at the end of the year. I mean that. So the customer may really buy it to run on one CPU, right? 100% of the CPU. But if they really start using these resources and then they increase the logical partitioning to use 2.5, on an average, no problem. End of the year, we'll come back, we'll ask them to really pay for more. So that way we'll never really say, don't do what you got to do, right? So, because the software is not going to do anything. I mean, it's not going to shut itself off. I mean, it's going to run, If you give it more resources, it's going to consume more resources. But end of the year, you should be able to pay for that, right? So, storage virtualization. Okay, we talked a little bit, a lot on server virtualization, but storage is really, this is another logical abstraction, right? I mean, it's an abstraction layer between your physical storage and what you really see at the, at the application layer. That also we have always really had, even before, the classical storage virtualization products really, are available from, storage vendors like IBM, EMC, and all that. We have had some level of virtualization, in storage. I mean, the whole RAID system is really a virtualized system, right? I mean, you stripe on multiple drives, but to an application, doesn't really care. I mean, so there is an abstraction layer there. RAID 0, RAID 1, RAID 5, I mean, they are all virtualization. I know about AIX systems, right? In AIX systems, there was always, you assign to your file systems, right? I mean, you assign logical drives, right? And then there is a mapping of logical to physical really done, underneath. So there is that level of virtualization has always been there, but there is another layer that really has come in, and it's becoming more and more popular, where multiple drives, multiple resources from different vendors can now be combined to make it look like a uniform resource that is available to the applications, right? So that is really what storage virtualization is providing. And even in storage virtualization, I mean, there are different types of virtualization. I mean, you have block level virtualization where it's really, this is disk, right? DASD, direct access storage device. I mean, you're really accessing physical blocks and you're really virtualizing that at that level. And then there is another layer of virtualization at the file level. So you could really take multiple file systems and make it look like a single file system. So you have, like NTFS and JFS, and they all really look like a single file system. And when you want to really open a file, you say open, read, write, close, right? I mean, and and you translate those commands into actual individual NTFS commands or JFS commands. I mean, so that's another layer of virtualization. Right? And the third layer is really the virtual tape. I mean, I just pulled it out as a separate thing because this is really where it's an emulation type of virtualization, where you're taking a disk drive, make it look like a fast, streaming tape device, right? Client virtualization is really at the desktop level, right? I mean, so at the desktop level, you really have, there are multiple ways to do it. I mean, we all really, a lot of times we load VMware and really have, another operating system running. So that's one level of virtualization, right? So that means within your own desktop, you really have multiple environments that you're setting up so that you have a virtualized environment and maybe a base environment on which you really run. And then there's another layer is level of virtualization is where instead of the desktop really having the whole thing, this desktop image is somewhere out there and that is being projected to you, right? And your keyboard and display is really remoted out from there. So you really have another layer of virtualization. So two types of virtualization. So you do it at the desktop layer or in the on the server side. Right? Again, lower cost of implementation, lower TCO. Actually, in one of the companies that I used to work for, I mean, actually prior to the third time I came back to IBM, right? So that we had a call center. We had in the call center there were many seats, around 100 seat call centers, and initially we had PCs in all those call centers, and that was the time we had diskette drives in those PCs. Right? These call center folks, call center employees would really bring in diskettes with viruses on them, and we had to have 2 or 3 help desk people completely dedicated to just support the call center. All they did was clean up the viruses, brought the call center PCs up and running so that they could really, the CRM system could be accessed by the call center employees. But then we said, okay, we're going to shut all that off. We're going to take that and then put it on a server and really use Citrix virtual machine servers to really remote out the display, and we gave them thin clients, and that really made it much easier for us to manage the environment. So that was in terms of lower cost of management, I mean, I've gone through that myself in my own career. I mean, that's network virtualization is again, this is really on one infrastructure, one physical infrastructure having multiple networks being run. We all probably use VPNs, right? I mean, to get, so that's one way of virtualizing on top of the internet itself, right? Then we have all used VLANs, where we have really taken, geographically dispersed, networks and created a LAN out of that, right? So that you can really have, one subnet defined on that LAN. So that's another type of virtualization. So VLANs, VPNs really are network, and hypersockets actually, I don't know how many people really know. On the mainframe, that's that's on the mainframe, it's also on the P series now. On the mainframe, because you have the ability to create virtual machines, there is the inter-machine communication really is completely in-memory communication, so you don't really go out into the network and then come back in. So that piece of code is really